Assalamualaikum warahmatullahi wabarakatuh. I would like to welcome everyone back to our class after a 1 week unexpected break due to the flooding. And I hope, our classmates in Pahang and Selangor already, at least, partially recovered. And we have to go on, we have to continue. We cannot afford to wait any much longer. This is toward the end of the semester. Given that constraint, we will try to cover, whatever we could. And of course, I know some of you are helping our victims. That's very good, because the government, I don't think the government can handle the problem. Helpers are coming from just citizens of the country. So before we start, do you have any discussion, any comment, question from the last class or anything? I have, some discussion in the WhatsApp. One or two people did ask question, and we have some sort of discussion. That was good. Anything today before I start the class? No. Okay. If there is nothing, like I said, our midterm would be the Wednesday. Okay, this Wednesday, 8 p.m. All right. Is that a share screen? Did I share screen already? Okay. Screen the share. Forward other. All right. Okay. So test is on Wednesday. This Wednesday, 8 p.m. So if you think of an excuse, make sure it's a valid excuse. If your cat is giving birth, or something that is personal, don't tell me. All right. If you want to tell me excuse, give me excuse that is as per university policy. All right. Other than that, we should try. Okay. Don't make excuse to avoid. So make sure if you have a problem, overcome the problem, and try your best. So don't just create problems, small things to become excuse that I cannot take the test. That is not the way, right? That's not the way. Otherwise, I cannot satisfy everybody all the time. All right. Okay. So I will write down here again the test, but I already post on the WhatsApp, so there is no excuse for anybody to know this. Wednesday berapa bulan? 29. Wednesday 29 of December 21, 8 p.m. So 8 p.m. at night, everything already cool off, quiet. So that's a good time. Okay, all right. And the coverage is the same. Okay, coverage is just like I mentioned before the break, the holiday. The coverage will be up to the point where we discussed it. So there is no new topic, and I think we have extended time, to prepare for it. So today I'm going to discuss the last part of that chapter. This is what you call the Lagrangian multiplier method. So this is the last part of that chapter. Lagrangian. Actually, it's under the topic of constraint optimization problem. So if you talk about this term, so become constraint maximization or minimization. So it's an optimization problem. We already have discussed optimization problem in linear programming. but this is a new. So the problem is the same. You have objective function, maximize, and objective function. All right, objective function subject to a constraint. The only problem here, or the only difference, would be both are functions. So you see here, you have objective function, all right? And the constraint is also a function. And the functions are functions of two or more independent variables. Okay, all right. So that is what you call optimization problem or constraint maximization, minimization, and there is a specific name. We call this Lagrangian multiplier method. Lagrangian multiplier method. I want to make sure that our spelling is correct. Lagrangian multiplier. This is 14.5. Lagrangian 14.5. Lagrangian multiplier method. Okay, that's the name of the method. So we have the problem. Here, it's not just maximized. It can also be minimized. So I put a bracket on the top. So you can also have a minimization problem. So you can minimize or maximize. But in terms of the method, it's the same. So our problem here, I actually have stated the problem there, but we want to be more specific, okay, in terms of the function. So you want to maximize, let's say we start with maximize. Maximize objective function. Objective function is equal to f of y. So that is our objective function, subject to a constraint. We denote that by g of xy equal to k. K is a constant. So that is the problem, right? You maximize or minimize an objective function, which is x equal to f of xy, subject to a constraint denoted by g of xy equal to k, where k is a constant. All right. Okay. So that is our problem. Now, when you have the problem, what you want to do here, you want to solve it. Now, the way to solve is the following. You have to write it in terms of Lagrangian function. So you call it L. L means Lagrangian function. And that Lagrangian function is equal to the objective of xy plus the constraint multiplied by a certain multiplier, which I will explain after. So g of xy minus k. So this is what you call Lagrangian function. Right? Lagrangian. So what we did, what we did is you combine both the objective, and then the constraint, you put the objective here, and then the constraint, you put there, You combine both by what? By introducing that multiplier. So that one you call the multiplier. This is apa kita panggil? Saya lupa dah. That's the multiplier. Anybody remember? Gamma, beta, alpha. Lupa. Nanti we call it multiplier. All right, lambda, yeah, lambda. That's a lambda. Sama tak sebut. That's a lambda. So the multiplier is denoted by lambda, and that's multiplier. It's a variable. Okay. I'm not sure if it's a constant or variable. Should be a multiplier. So multiplier normally is a constant. Okay, so that is a constant. So you have the multiplier, and then you have the objective, and they are combined in that manner. Okay, so the constraint, what you need to do is you have to rewrite the constraint. Just rewrite from the form that was stated in the problem into g of xy minus k equals 0. So that is the thing that you need to write. And from here, you have that form. Okay. So example, say you have 2x plus 4y equal to 200. Suppose that is the constraint. All right. So what you do, you simply bring the constant 200 to the left, and you have the form. Okay, you have the form in the Lagrangian. All right. Okay, so that is what you call Lagrangian function, and we are going to solve the problem by using the L function. All right, you're going to use the L function to solve our problem. So what you want to find here is you want to solve the problem. Okay, you want to find x, y that solve the problem. That means that maximize or minimize the objective subject to the constraint. So in short, we just call it, you want to maximize, or you want to find x, y that solve the problem. That solve the problem. We know the problem is. Okay, so you want to find the solution. Okay, x, y that solve the problem. Now I want to go back to the problem. Did I mention maximize, minimize? Yeah, I did. So you have maximize, minimize. Then you have the Lagrangian function. And you want to find the solution. That is, you want to find the x and y that solve the problem, or that maximize or minimize the objective subject with the given constraint. Okay, now how do you solve it? Okay, the method is the following. So this is the method. What we do first, you take the partial derivative. Okay, you take the partial derivative. So we call this first order condition. That means it's partial derivative. First order conditions. In short, we call it FOC. Okay, it's like free of charge, but this is not free of charge. This is first order condition. What you do, you take the first derivative, the first partial derivative of L with respect to the x, the y, and the lambda. So that lambda, probably the lambda is a variable because you are going to take the derivative with respect to lambda. So maybe the multiplier is a variable. All right. So the first order conditions FOC are Lx. Okay, Lx equal to 0. You call it number 1. and then I take derivative of L with respect to Y, set it to 0, call it number 2. So this is like the first order condition, yang critical point, okay? And then I take derivative of L with respect to lambda, set that to 0. So you got 3. So I have 3 equations. I have 3 equations, and we have 3 variables, but here we just need 2 variables. So we're going to make use of these 3 variables to solve, not variables, equation. Solve for x, y. All right, that will satisfy, or that will solve the problem. Okay, so basically we're going to use partial derivative and nothing new. Okay, you have a system of equation here. It's nothing new. We already knew. All right, the function is a new function, which is Lagrangian. So if you look at more detail, all right, if you look at more detail, you will see the respective partial derivatives. So I will write it down here. Okay, I write down here again. You have Lx. Okay, Lx. What is it equal to in terms of the objective and the constraint? So if you look at the objective is a function of x and y. So you take the derivative of f of x, okay? And then you look at the constraint in the form, you will see there is g is a function of x and y, but it's multiplied by lambda. So you have lambda multiplied by gx equal 0. That is number 1. I'm going to rewrite, what I have just written in more detail. And then L of y, I have the partial derivative of fx of f with respect to y plus, okay, lambda is multiplied to the function. And you have g as a function of y, so you got gy equal 0. So that is number 2. And number 3, when I take derivative of L with respect to lambda, what do I get? Lambda is only lambda to the power of 1. If I take derivative with respect to lambda, what is it equal to? Just 1, okay? So just 1, so that will be what? Derivative with respect to lambda will be only the terms in the bracket. That is the constraint. So it's gxy minus k equal 0. So that is our number 3. So that is our what do you call it? Our first order conditions. Okay, any question? So if you look at the constraint, I just look at the constraint. Okay, the constraint I got lambda multiplied by g of xy minus k. Now g of xy minus k is multiplied to the lambda. So if I take derivative with respect to lambda, what is it? 1. Okay, 1 multiplied by what? Multiplied by everything in the bracket. That is the coefficient of the lambda. Okay, so or what you can do, you multiply right away, or you can multiply lambda g of xy minus lambda k. So what is derivative of L with respect to lambda? So that will be what? G of xy minus k. So that's how you get number 3. All right. So if you're not sure what you do, you multiply out with the lambda for each of the terms in that bracket. Okay. All right. So that is the method. So you have 3 equations. You solve it. Okay. You solve. You will get x, y. And that is our solution. So that's it. Okay. Now, you want to look at the second order condition. Second order condition is the second derivative condition. Okay. Second order condition, that would be equivalent to the second derivative condition. Sama, tapi it's a different form. So what is the second derivative condition? Now the second order condition, which we will discuss later on. Okay, so the second order condition, what you do here is I form, they call it Hessian matrix. So just call it Hessian matrix. Okay, Hessian matrix denoted by HB. Actually, there is another word here. Bordered. Okay, bordered Hessian matrix HB, and that is equal to the following. You got 0 gx gy, and then gx lxx lyx, and then here gy lxy lyy. So the Hessian matrix, I discussed this when we do the matrix. Yeah. But what this matrix consists of? Firstly, gx gy. Gy, very easy. You know, gx gy is the derivative of the constraint with respect to x, with respect to y. So what you need, you find gx dy. All right. Now the second partial derivative, what we need are what? Lxx. So you got already Lx. And then you take that derivative with respect to x, you got L. And then I already have Ly. So take the derivative with respect to y, I got Ly1. And then I got Lx. Okay, take the derivative with respect to y. So Lxy. And then Ly, take derivative also with respect to x, we have Ly. So you got that matrix. So you form the matrix in that order. Okay? But now we postpone this. Okay? We postpone this until we cover the matrix chapter. So that one we'll do afterwards, later. Okay? So we'll come back. We will do afterwards. Maybe in a few more weeks. So that is the method. First, or as of now, we will just focus on the first partial derivative or the first order condition. Okay, any question, anything? All right, so we look at example. Now, suppose you have the following. Let's say I have a problem, I want to maximize z equal to f of xy equal to say 25 minus x squared minus y squared, subject to constraint 2x plus y equal 4. So suppose you have that problem. So what you need, we know the L is equal to what? The L is equal to the objective plus the lambda multiplied by the constraint. All right? Constraint in that form. So what you need from the constraint, you have 2x plus y equal 4. You rewrite it, bring the constant to the left. You have 2x plus y minus 4 equal 0. All right. So you have already that form. And then you put into the function. So our Lagrangian function would be equal to what? F, the objective is 25 minus x squared minus y squared plus lambda times 2x plus y. I'm sorry. Don't forget that 4. Minus 4 equal, no, equal to 0. Okay. So that is our Lagrangian function. Okay. All right. Finish, because I need to move to another page. I'm done. Okay, right now. Okay, siapa? All right. So what you do next is you take the partial derivatives, f of t. So first, Lx, all right? Lx, what is it equal to? It's equal to negative 2x minus 2 lambda. Set that to 0. Okay, so that is our number 1. And then I have Ly, all right? That will be equal to what? Negative 2y minus lambda equal 0. Set it to 2. And then I have L lambda that will be equal to 2x plus y minus 4 equal 0. That is number 3. Okay. So if you are not sure about the constraint, all right, how you take the derivative with respect to lambda, just to get familiar to the method. This thing here, if you're not sure how we got it, you multiply it with the lambda. So I got lambda 2x plus lambda y minus lambda 4. Okay, so if you do that, then you can see clearly. But as you do a few problems, then you know how it works. So if you take Lx, okay, if you take Lx, what do we have? I have 2x. Okay, 2x is clear. That's from the objective. Now, the second term is 2 lambda. So how did I get 2 lambda? 2 lambda is this. I got what? If you look at the objective here, 2x. This is 2x, which is the x term lah. So derivative of 2x is 2. But you multiply that by lambda. Okay, so it's 2 lambda. And to see it, you multiply lambda by each term, that's what you get. So if I take derivative of this function here with respect to x, what is it equal to? Lambda 2 or 2 lambda. Okay, so that is the thing. So if you multiply lambda into each of the terms in the constraint, that's how we can see it better. But later on, when you are clear already, you don't have to do it. And then for the Ly, okay, I have to negative y squared. So you got negative 2y. Now, how did I get lambda? Because you see here, lambda or y, only y. So the derivative of y is what? 1. But coefficient is what? Lambda. So you got lambda. Or you can see here, lambda y. Derivative of lambda y is what? Lambda with respect to y. And then here, you got that. Okay, so that's the Ly. Now, if you look at L lambda, if you take derivative with respect to lambda, that's the lambda. Coefficient of lambda is not just one term, it's everything in the bracket. In fact, it's the constraint. So if you take derivative with respect to lambda, what is it equal to? 1. But once you multiply by the terms in the bracket. So that's how you get 2x plus y minus 4. Or another way to see it, you multiply by lambda by each of the term. I got lambda 2x, lambda y minus lambda 4. So take the derivative with respect to lambda, what do I get? You get 2x, you got y, you got 4. Okay, with the signs. Okay, all right, so that's how you get L lambda. So now we are going to make use of this 1, 2, 3 to solve the problem. Okay, this is the way. We make use of 1 and 2 first. All right, you make use of 1 and 2. Yeah. Yes.
For the Ly, the lambda is negative. Supposedly it's positive.
The lambda is
Positive.
Positive.
Negative 1.
Negative 1. Kemudian negative 2y. not just not just the x. Betul, thank you. Be the y also negative. Cuman saya boleh dapat negative because you got a plus here. Okay, that should be plus. Thank you. Bukan ly aja, lx pun kena plus juga. Sini pun plus. That's correct. Alright. So how did I got the negative sign? Kenapa? Anybody knows? Nobody knows. Saya seorang yang
Not
tahu.
sure, sir.
Sebab saya pun tak tahu. You know? You got a plus sign. The negative sign is only on the k, on the constant. So it should be negative 2x. Betul lah. Here you got lambda 2x. So lambda 2. So it should be a plus sign. Okay. Actually, if you put negative sign tu balik cuba. You can try, you know. If you do it negative sign, dapat sama juga. So you got a plus sign there. We make use of 1 and 2. Okay. And then you use 3. Now, from 1 and 2, what you do, you write lambda in terms of x and y. So we do this. From number 1, you will simplify it this manner. You bring all the variables x, y to the other side. The constants also to the other side. So I have lambda equal to what? Equal to 2x. You bring the 2x to the right. I got 2x. And then divide by 2. So that is equal to x. Yeah. And then from number 3, from number 2, lambda is equal to what? You bring the 2y to the other side, 2y. So what I have here, I got lambda equal to something from first equation. Second equation, I got lambda equal to something. Therefore, you have what? Lambda is equal to x, lambda is equal to 2y, therefore x is equal to 2y. Okay, so from here, we conclude lambda is equal to lambda. Lambda is equal to lambda because they are talking about lambda equal to lambda. So lambda equal to lambda, that is x equal to 2y. So you got x in terms of y. Okay, so the lambda is out, no more lambda. You have in terms of the original variables, x, y. So what you do next? You make use of number 3. Okay, so we substitute this relationship, x and y, into number 3. So you substitute x equal to 2y into 3. Okay, now you do the substitution because I think everybody knows. So what do you get? Y equal to? Okay, anybody get it? What do you get? Okay, anybody got? The first person who get it, let me know. Semua kau tak dapat ke? Substitute
Is it 4 over 5, sir?
4 over 5. Already got 4 over 5? Okay, good. Let us find out. Okay. You have x equal to 2y. Okay, substitute into number 3. So substitute into 3. You got x equal to 2y. X equal to Y, so kita punya objektif nombor apa? 5 to X plus Y. So you put into the number 3. So number 3 is 2X plus Y minus 4. Itulah 4, 5 lah. So you got 2X. So 2X, that will become 2Y. Okay, plus Y minus 4 equal to 0. All right lah. So you got 5Y equal to 4. So Y equal to 5 over 4. So I got 5Y equal 4. That will be Y equal to 4 over 5. All right. So when you get 4 over 5 for the Y, you find X. So again, you have to substitute into X. How do you get X? You can substitute into number 3, boleh tak? But I already have the simpler relationship. Yeah. Then you can use that one. So X equal to 2Y. So I use that thing. So X equal to 2Y. So what do I get? I got 2 times 4 over 5. So we got 8 over 5. Okay, so that is our solution. All right, of course, the second order conditions, we will do it afterwards, later on. We need to get the second partial, but we will do it when we discuss about the matrix algebra. Okay. Okay, I would like you to do one question from the book. I'll give you another example. All right, so second example, number 2. I would like you to do the question number 3. Okay, do question number 3 in 14.5. That is the minimization. Minimize, the objective subject to the constraint. Okay, so I want you to do it now. You get the Lagrangian, and then you get the first order conditions. You don't have to solve that. Okay, we will do step by step. So I want you to get the first partial. When you get it, the first person who got it, let me know, so that we will continue. I will go through it, and then we can continue with the next step. So I give you 3 minutes to get the first order condition. Number 3 though. Okay, you got it. So that question number 3, all right, I will just write down the Lagrangian. So the Lagrangian is equal to what? Is equal to the objective, which is 3x squared plus 5y squared minus 2xy. That is the objective. Plus lambda, the constraint, I have x plus y equal to 5. So you do the the rewriting. Okay, you bring the 5 to the other side. So I go x plus y minus 5. So everybody got it? All right, good. Now you take the first order conditions. What is Lx? Lx is equal to 6x. Here's 6x. And then there is another term in x here. So minus 2y. And then you got the constraint, okay, lambda. So lambda x. So that is plus a lambda equals 0. That is number 1. So if you're not sure, you multiply lambda like what we did earlier. Okay, you multiply lambda by x, lambda y, lambda 5. Then you can see it more clearly. That is just, the idea. Now you take ly, what is it? You got 5y squared. So that becomes an ny, and that's 10y. Okay, 10y. And now I got another y there. So that will be 2x plus lambda multiplied by y. So that is a lambda 2. And then number 3, a lambda, that will be equal to everything in the bracket, x plus y minus 5 equal 0. That is number 3. Okay, everybody got it? Good. If you don't, check. All right, check where is your mistake. All right, check where your mistake and then understand it. Okay, so now what you do next is that, saya pun tak sure. So I want you to do the second step. Solve for the x and y. First, you use 1 and 2. Okay, just write lambda in terms of x and y, and then you get rid of the lambda. After that, you substitute into number 3. Okay, let's start. Go ahead. Okay, if you use 1 and 2, you write lambda in terms of x and y, and then you equate the 2. So what do you get? X in terms of y. Anybody got it? The first person get it, let me know. What do you get? Because I get my answer. I want to compare with you. So maybe I'm wrong, maybe I'm right. Okay, what do you get? Anybody? Huh? Anybody get it? Hello? Hello. Ada orang terang ni? Okay. What do you get? X in terms of y from 1 and 2.
3/2y, sir.
3/2y. 3/2y. Okay, tunggu sekejap. Kita buat. Saya dapat macam lain sikit ni. Kita buat. Anybody else get a different answer than 3/2y? Okay. 1 and 2 betul lah. Saya punya ni betul lah. 6x minus 2y plus lambda. Okay, betul tu. Okay, so let's see. From number 1, what do I get? I get lambda equal to, you bring the y becomes positive, minus 6x. Betul lah? Okay. And then from number 2, lambda is equal to 2x minus 10y. Okay. You take, you equate both. So therefore, 2y minus 6x equal to 2x minus 10y. You bring the x to one side, you bring the y to the one side. Am I right or am I wrong? Cuba cek ya. So you bring the x to one side, so you bring the y to the left. I got 2 plus 10y. Yeah, betul tak? 2 plus 10y, that is 12y. You bring the negative 6x to the left, I got 8x. So y is equal to 8 over 12x. That is 2 over 3. 2 over 3x. Y equal to 2 over 3x. Now, you may not find y in terms of x. Maybe the way you did it, you get x in terms of y. Okay, so you can also get x in terms of y because there is no specific rule on that one. So if you do x in terms of y, then you got x equal to 3 over 2y. Okay, so either you got this one or you got that one. What did you get? 3? Okay, 2 over 3, 3 over 2. Which one did you get? X equal to 2 over 3. Oh no, x equal to 3 over 2y or y equal to 2 over 3x. Okay. Right. So anyway, okay, the method is you make use of 1 and 2. All right, you write lambda in terms of x and y. At the end, you will get either y in terms of x, like what I did here, or you get x in terms of y. It's up to us, you know, which one you want to get it first. So it doesn't matter. So what next is that? What do? We substitute y equal to 2x, 2 over 3x, or x equal to 3 over 2y into number 3. Okay? All right, finish it up. Betul ke saya? You check, you check mine. Is this correct? Okay, what do you get for the solution? Okay, what do you get for x and y? Anybody?
Y
x3
equal to 2.
y equals to 2 lambda negative 14.
Lambda tak payah cari. You don't need lambda, you need x. X, what do you get for x?
3
3. So you got y equal to 2, x equal to 3. Okay, let's see. Lambda tu tak apa. We don't need lambda as of now. Actually, for our purpose, we do need the value of the lambda. So what you do next is you substitute y. I use the first one that I got. Okay, y equal to 2 over 3x into number 3. So what next is that we substitute y equal to 2 over 3x into number 3. So what you have would be x plus 2 over 3x. Okay, because y is equal to 2 over 3x minus 5 equal 0. Now you bring the constant to the right, and then you solve for the y, for the x. So I have 5x equal to 5. In fact, 5 over 3x equal to 5. So you can see here, everything cancel out nicely. So I got 5 times 5 divided by 3. Balik. Okay, multiply by 5. 5 multiplied by what? Multiplied by 3. Multiplied by 3 divided by 5. So 5 to cancel out equal to 3. So you got x equal to 3. You are right. So x equal to 3. Therefore, y equal to what? Y equal to 2 over 3 times 3 equal to 2 by, again, substitution. Okay, so describe the method lah. You substitute dengan masuk je titik berapa. Alright. Okay, so that would be the solution. Alright. Okay. Now I want to give you another example, okay? Because this topic is quite important. I'll give you another example. Okay, you after when you go home, you read the example in the book. Okay, now I want you to do this. I give you 10 minutes. All right, I want you to complete this example. So here, the problem is I want to maximize z equal to x to the power of half. X to the power of half, y to the power of 3 over 4. Kecil sangat. Ini 3 over 4 tau. Bukan 3 over 4. I'm sorry. Kita balik. Maximize z equal to x to the power of 1 over 4. Y to the power of 3 over 4. Subject to constraint for x plus 2y equal 50. All right. So I want you to solve this. All right. Find x, y. Okay. Go do it now. I'll give you 10 minutes. Siapa dapat dulu? Saya dapat dah. Okay, who get? Anybody get it? Get the x in terms of y? First step. We do the first step. You got x in terms of y? Solving the equation 1 and 2. Anybody got it yet? X equal to berapa y? Or y equal to berapa x? Okay, siapa dah dapat? Not yet. But first person get it, let me know. So here, our Lagrangian function, I will do the Lagrangian 1 over 4 y to the power of 3 over 4 plus lambda multiplied by 4x plus 2y minus 50. Okay, so make sure you rewrite the objective and constant. Okay, bring the constant to the other side. First order conditions. Lx. What is Lx? Now you get x to the power of 1 over 4. So 1 over 4 x. You reduce the power by 1. So that is negative 3 over 4. Y to the power of 3 over 4. Plus, here you got lambda multiplied to 4x. So that will be 4 lambda equal 0. So that is our number 1. Ly. You got 5 y to the power of 3 over 4. So you take the derivative with respect to y. I got 3 over 4 x to the power of 1 over 4 y. Reduce the power by 1, negative 1 over 4. Plus 2 lambda equal 0. That is our number 2. Okay, number 3, L lambda. What is it equal to? Just the constraint. X plus y minus 50 equal 0. Okay, so by now, if you look at the way we do the Lx and Ly, so by now, you don't have to rearrange the terms already now because we already know, okay, how to do the derivative. We know what is the variable and we know which one is the constant. So for example, if I want to do Ly here, y is the second term. So you just do it right away from there. Okay, you just bring 3 over 4 down, and then you maintain the x where it is, and then you just handle the y. So I think by now we should be able to recognize that. Okay, now check your first partial here. Anything that you did wrong, make the correction, then we move on. So what do you get in y in terms of x or x in terms of y? Anybody? Ya, terasa berapa ke? Berapa? Tak kira. Salah ke betul ke kita kira lain. Okay, yang penting you did try. Okay, siapa dapat? Cakap. I just need 1% to tell what is your answer. So don't worry, it is wrong or right. You must be proud because you solve the thing. Okay. So what do you get? Anybody get x in terms of y or y in terms of x? Cepat-cepat. Soal cakap. Setakat ni seorang je yang cakap tadi. Okay. I know only 1% who tell me the solution. So now, if possible, another percent lah. Alright. Kalau tak ada pun tak apalah, the same percent pun tak apa. Okay. What do you get? Anybody? Saya dah malas dah panggil nama. Okay, cepat-cepat. Hai, seorang pun tak dapat ke? But you see here, it's a little bit, maybe you can say difficult, but a little bit messy. You have to be careful, okay? So if you look at number 1, you have to write lambda in terms of x and y. So what do I have? I have from number 1, you bring the x to the other side. So I got 4 lambda equal to negative 1 over 4 multiplied x. negative 3 over 4 y, 3 over 4. Okay, and you bring the 4 to the other side. All right, so I bring it now, becomes 4. And then from number 2, I got 2 lambda equal to, you bring everything to the left, to the right, I got negative 3 over 4 x 1 over 4 y negative 1 over 4. Now you bring the 2 to the other side, multiply with the 4. So now you have negative 1 over 16. The second one, you got negative 3 over 8. Okay, so you got 3 over 8. And you got everything already. So you equate the 2 because they are also equal to lambda. So what do I get? I get negative 1 over 16 x to the power of negative 3 over 4 y to the power of 3 over 4 equal to what? Negative 3 over 8 x to the power of 1 over 4 y to the power of negative 1 over 4. Now negative become positive. And then you bring the x to one side, y to one side, the constant you bring to the one side. Okay, so the way you look at here, you bring the 16 to the right, okay, and then you bring y to the left, x you bring to the right. So what we have is now y to the power of 3 over 4. I bring the y to the left, I got y to the power of negative 1 over 4. Equal to, you bring the constant 16 to the right, I got 3, 16 divided by 8, and then I got x to the power of 1 over 4. You bring the x to the left, so you divide by x to the power of negative 3 over 4. Okay, so here, what is it equal to? Y 3 over 4 divided by y to the power of negative 1 over 4. What is it equal to? Equal to y. Okay, and then here you got 2, 6, 6x. So you got y equal to 6x. Now at the end, you will get a nice relationship. Okay, y in terms of x. So probably I need to check how do I get y. So you review back your basic operation. Okay, so if you're not sure, I got y to the power of 3 over 4 divided by 1 y to the power of negative 1 over 4. So you bring that thing up. So the power becomes positive. Okay, now you have y to the power of 3 over 4 multiplied by y to the power of 1 over 4. So you multiply y and y, the power you add. So that will equal to what? Y 3 over 4 plus 1 over 4, that is equal to 1. So you got y. Similarly for the x. Okay, similar. So you bring the x to the power of negative 3 over 4, you bring it up. So become positive. So you multiply. So the power you add, you get x to the power of 1. So you got y equal to 6x. And then you, of course, you substitute into number 3. Okay, you get the solution. So this one, finish up. If you haven't finished, you finish up at home. Okay, all right, good. So I already looked at 3, okay? 3 different types of functions. So the method is the same. At the end, you will get x in terms of y. The only difference is the degree of difficulty. You know, some types of function a little bit more difficult. Others are more simpler. But the thing is, we still use the same method. All right. Okay. Now we look at application. So application in economics, basically economics. I do not know whether in business you have this, but I think probably you do. But I will consider, as per the textbook, you have application with the economics. So application, we look at 1, utility. Okay, utility. Now, utility, what do we do? In economics, our problem is you want to maximize. Okay, you want to maximize utility. Now, what is the constraint? If you have taken principles of economics, you maximize utility. What is your constraint? You cannot maximize utility indefinitely. Okay, you have the constraint. Now, what is our constraint in maximizing our utility? Apa constraint? Subject to what? What is the limitation of your maximizing utility? Your real life, because this is a real life problem. What is your constraint? You know, every month you want to maximize utility. You want to buy a car, you want to buy phone, you want to buy everything. But what is the constraint that stop you from buying everything you want? Apa dia?
Budget.
Budget lah. Because every month you have a budget. Nobody has unlimited budget unless you are Bill Gates. Maybe Bill Gates pun kaya sangat pun ada dia nak beli apa, beli bulan tak boleh kok. Alright. So you have a constraint subject to the budget. Okay, subject to your budget constraint or income constraint. Because every month we have limited income. Especially during the PKP, lepas tu banjir pula. Okay. Siapa yang belum tolong orang banjir itu pergi ke Pahang atau ke Hulu Langat. You know, in Bentong pun dah cukup dah, you know. People are still in need of help in terms of cleaning up. That is the more difficult part, you know, cleaning up. Cleaning up. Hujan, you know, actually the rain is only 2 days, you know, 2 days of heavy rain. But the flood is bad. I think one reason, okay, because kat Pahang, kayu balok habis dah, you know, hutan banyak dah buat balok. And another one is the dam, you know, the dam. Normally during I was small in 1970, you know, that was bad banjir. Tengok, okay, if you go to YouTube, probably there is a program, banjir 1970 or 71. During that flood, it's very bad. It's national disaster. But that flood take 3 weeks to develop. 3 weeks to develop. So you have time to move, you know. You have time to go away. You know where the place which is safe. But now, our flood, 2 days of raining, suddenly the water level rises to your neck. You don't know where to go. You know, it's so sudden, you know. So the reasons are different, the factors are different. People are making use of different resources, you know. So at the end, macam tu, flat 2 hari naik teruk, lepas tu habis. So that is about the flat. So you maximize utility subject to the budget constraint. And then second example would be production. Okay, production, you maximize. You maximize production. This is for the firm. Okay, you might maximize production. Subject to what? You want to produce, of course, as a company, you want to produce 2,000 burgers, or 5,000 burgers, or whatever you are selling. You want to produce as much as you can. All right, but what is the constraint? The constraint is what? What is the constraint? For business, if you want to produce something, what is your constraint? Again, constraint is the budget. Betul tak? Ada constraint lain? Subject to input constraint, your labor, your capital, your resources, things like that. So subject to cost constraint. Or sometimes they call it expenditure. Expenditure, boleh bagi expenditure constraint. Number 3, cost. Cost is related to production, all right? Of course, when you talk about cost, you want to minimize, you want to minimize cost, subject to what? Subject to the capacity of your company. So subject to production. All right. Let's say you want to produce 2,000 burgers. So what is the minimum cost of doing that? So that is to minimize cost given that production constraint. Oh, yeah. All right. So that is the basic applications that we are looking at. Now, utility is given in example number 4. Okay, example number 4, and then they give you the diagram on figure 14.13. So I want you to look at example 4. I want you to see the diagram where you have the optimum point. Okay, so you want to maximize utility, and then you are given the budget line. Now, one important aspect is the budget line. Now, budget line or income line is a constant. Constant. It's linear function. Okay, linear. From pxx plus pyy equal to I. So that is our income. All right, where you have two goods, X and Y. X and Y quantities of two goods. Okay, two goods, X, Y, whatever they are. Px, what is Px? It's the price of X. And then what is Py? Price of Y. And the I is income. Now, when you talk about limited income, so that will be constant. Okay, income will be a constant. And for that matter, Px and Py are also constant. So this is a constant, that is constant. Okay, Py constant, Px constant. I put arrow here. All right. So if you want to find the budget line, we put the values of the constant into that form, into the budget line form. Px, Py, Px times X plus Py times Y equals I. Okay, so if the price of X equal to $2 or 2 RM, and the price of Y equal to $4 or 4 RM, and our income is equal to 40. So what is our budget line? The budget will be equal to, you put everything into the budget equation. So what do you get? You get the budget line. Linear 2x plus 4y equal 40. So that is our budget. All right. If you look at example number 4, you see here the budget line 2x plus 4y equal to 40. So what is it? 2 is the price of X. Okay. 4 is the price of Y. 40 is your income. Okay. So that is the form. Px times X, Py times Y equal I. I is income. All right. So you see here, it's just a linear function. Linear. So linear function, if you look at the graph, okay, if you look at the graph, you will get a straight line. You draw it X in terms of Y. You will draw X, Y. So the budget line, boom, it's like that. Okay, linear function. 2x plus 4y equal 40. So doesn't move. Okay, that is our limit. That is constant because income is a constant. So what do you maximize? You maximize your utility given that thing. Okay, so our utility, which is given by that equation, u equal to x squared plus y squared, the function will look like this. Okay, this is u0, that's u1. So you want to maximize your utility. That is u3. Okay, now if you have taken economics, you have seen this diagram. Now u0, I ask you this question, whether given the budget line, okay, given our income, given income, okay, the budget line, can you achieve level utility U0? Boleh ke tak boleh?
Yes.
Yes, because that is within your budget. All right. If you consume here, you still have more. You have extra income. Yeah. Or you can consume here. You can consume there. Okay. But you are not. You can be what? You can do better than that. Given your income, you can do better than that. So what can I do? I can get U1 with the same income. You see, I can get better utility consuming here on U1. Okay, all right, so good. Now, can you achieve U0? U0 plus U3?
Cannot.
Tak boleh ya. Okay, this one cannot. Why? Because you have to find another income. Okay, our level of income currently you cannot achieve. So that was angan-angan majnin je lah. Okay, that one you cannot achieve because that is beyond our income. All right. So U3 you cannot, but U1 U0 you can. But you want to find the best. Okay, you want to find the best solution given your budget. All right. So what you do, the best would be where? Will be just when the budget line and the utility so that is our solution. Okay, so you call it point E, that will be X and Y. So you call it X star, Y star. Okay, so the equilibrium point. So the equilibrium point will be the point where the U just touch the I. In other words, in terms of us, you see the slope of the utility function just equal to the slope of the budget. So that will be the point. That is our equilibrium or our solution. But for now, we're using what? We're using the Lagrangian method. So by using the Lagrangian method, what you are getting will be that point E. Okay, that point E. So how do I label it? So this is actually utility maximizing. That is the point we will get. The point E. Okay. So that is example number 4. I don't have time to continue with it. So I want you to forget about the example 4. I want you to study for the exam. Okay, example 4, we'll do it next week. So from now on, you focus on the things that will be on the test. On Wednesday, we will review some things if you want, or we will continue Wednesday. Again, if you have a problem, put in WhatsApp, okay? Don't just ask the answer, okay? Ask the answer is not solving the problem. You don't ask answer. You do it, you show your answer, I will check, okay? If I don't check, your friend will check. And then I will point out where is the mistake, okay? If you just ask me for the answer, you will not get the answer, all right? Because our problem is not to get the answer. Our problem is to find the solution. So when you find the solution, you have to use the method, all right? So the method is important. So answer, I can say the answer is 2. But how you get 2? That is more important. Okay. So we are not talking about the answers, we are talking about the solution. So if you are not sure, you do it first, take a picture, show in WhatsApp. Very senang. Okay. And then if there is a lot of correction that I will do it myself. I take my picture, not my picture lah, picture of my solution lah. And then I post back on the WhatsApp. Senang cerita. You can do it while you are lying down. Okay. Okay, good. So have a nice day studying. Okay. So I hope everybody. Yeah, sir. Okay.
Is this chapter include in the method? This one.
Okay, somebody answer. I don't want to answer this. Somebody answer. Will this be included in the midterm?
No.
No. Answer is okay. Tadi saya dah cakap tadi. Where were you? You know, I already pointed out the coverage for the midterm last week lagi dah. Okay, that doesn't change. If it change, that teruk lah saya ni. Saya ni jahat betul lah. You know, I'm not doing something fair to you. Okay, so the coverage doesn't change. The coverage will be the same. Alright. So itu saya kata tadi. Example 4 ni tak payah baca dulu. Okay, kita tunggu next week. Alright, what you learn today, forget it. We'll continue after Wednesday. Okay, from now to Wednesday, focus on the test, the material for the test. Okay. Yang tadi ni jangan campur, simpan je. Okay, simpan dulu dalam kepala, jangan fikir banyak. Alright. Partial derivative tak masuk tau. Partial derivative tak masuk. So don't worry about the partial. We'll worry about the partial after Wednesday. Okay? Alright. Anything else? Okay, if there is nothing, I will see you again on Wednesday. So Wednesday we have 2 classes. Okay, one in the regular time, the other is 8 o'clock at night. So you come both, all right? Because I want to discuss about something in the morning. So I will see you again. Have a nice time doing the questions, you know, study. I'll see you again. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Okay, thank you.
Waalaikumsalam, thank you, sir.